What's up guys, welcome back to another simplified astrophysics video. This video is going to be all about stars and stellar evolution. No, not Hollywood stars. Nope, not the Marshmello song called Stars either. Yes, these stars, those mysterious shiny objects full of crazy physics and amazing mysteries. Let's talk about those right after I run the intro. Alright, so we often see stars outside in the night sky, but what exactly are they? Well, a formal, really general definition of a star is that it's an astronomical object held together by its own gravity, and it's really bright. So what about these stars? Where are they located? How big are they? Are they really as small as they seem out in the night sky? Stars are scattered all over our universe. Many of the stars that we see in the night sky are located within our Milky Way galaxy. To many people's surprise, there is only one star inside our own solar system, and that star is none other than our sun. And trust me, the sun is the only star in our solar system. We would know if there was another one, because stars are not only incredibly massive, but incredibly bright. So we have these incredibly bright objects that are located really far away from us. How do we see them? We see stars the same way that we see any other object. The light from stars travels towards our eyes and forms an image. Because stars are so far away, the light that we see from a star takes a very, very long time to reach our eyes. So long that by the time we do see the image of a star, a significant amount of time has elapsed, and different things may have occurred in that star. Astronomers can analyze this using units of distance called light years, which is the length that the speed of light travels in 1 year. And that's about this number in miles. Let's take a look at an example of this. So here is Earth, and here's an amazingly intellectual, awesome observer named Amun on Earth. Star A is located 1 light year away from Amun on Earth. By the time the light from Star A reaches Amun's eyes, it's been 1 year, and that star may be different from the image that Amun sees. Similarly, let's say our amazingly intellectual, too cool for this world observer is observing Vega, a real star, located 25.05 light years away from Earth. The light that he sees from Vega is 25.05 years older than when it left Vega and headed to Earth. So now we know that stars are these incredibly bright objects that are incredibly far away from us on Earth. So how do they form? How do they survive? How do they function? Stars are born out of clouds of dust that condense together under gravitational attraction and heat. As stars form, they use nuclear fusion energy from hydrogen-helium interactions to shine out amazingly bright light and keep them from collapsing under pressure. The nuclear fusion energy that stars produce is absolutely amazing. It is 100% efficient. This means that it produces no greenhouse gas emissions, no carbon emissions, no radioactive waste, just pure energy for the star to use. Yo, that's kinda nice. Can we get some of that here on Earth? Yeah, it is pretty nice. We on Earth have been trying to achieve nuclear fusion energy for almost a century. Unfortunately, it's a very difficult engineering feat, and the results have been close but not fruitful. So stars are born and live a very nice life with nuclear fusion energy. The time for them to mature to adulthood it doesn't take that long. They're an average of about 50 million years. But what happens to a star at the end? Is there an end? Does the star ever die? Well, not exactly die. It's more that the star evolves. It all has to do with that nuclear fusion energy. Eventually, the fuel for that nuclear fusion energy that kept the star from collapsing, that fuel is going to run out. When it does run out, this will cause the star to collapse, albeit in a variety of ways, depending on that star's mass. Average stars on the lighter side, like our sun, will collapse into white dwarfs. These white dwarfs will mainly remain as calm white dwarfs unless they're really massive. More massive stars will result in novae or supernovae. This is when the star's entire core collapses and the whole thing just explodes. And even more massive stars may result in a special leftover in supernovae explosions we call neutron stars. These incredibly dense neutron stars have massive magnetic fields, and they can accelerate particles to extraordinary lengths. And finally, the most massive stars will turn into black holes. These mysterious warps in space-time deserve a video of their own. Check out this video in a card above to see more about black holes and the astrophysicists that discovered them. The entire process of stellar evolution is quite complicated. This diagram from the European Space Agency provides a good summary of the process. As you can see, different processes occur based on different states and masses of the star. Now, all those violent stellar explosions are quite peculiar. So what happens after these explosions and evolutions? Well, from the dust and debris of these explosions, the stage is set for new stars to form, and the entire rapid 1 billion plus year process repeats itself. So that's just a little bit about some of the most incredible objects in all of astronomy. Be it in their incredible brightness or the way they create energy, stars are just too amazing. And that's all I've got for this video. Hopefully you enjoyed it, and hopefully you learned something new. If you enjoyed that video, please go down below and leave a thumbs up to show your support. And if you like my channel, you like what you're seeing, well, go ahead and hit that subscribe button for me, because it really helps out a lot. And if you have any feedback, questions, comments, or concerns, don't hesitate to drop that in the comment section below, and I'll try my best to get back to you. I will see you in the next video.